Okay, hello everyone. Welcome back. This is Monday and Tuesday, November 9th and 10th. We're looking at permutations and combinations here today. And I don't think you've had these before. So I need you to watch close on this video, okay? And today's objective, to define and count permutations and combinations. Our essential question, how do we count the number of possible arrangements or possible groups? That's permutations and combinations. Just to review, remember we talked about factorial at the end of last week. And the example I used was like 4 factorial. That just means 4 times 3 times 2 times 1. Okay? Like right here, 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, that's a factorial. All right? That's when we want to arrange all the items. Remember, like 4 books on a shelf. How many arrangements? 24. But let's say we're running a race with 6 runners. How many different arrangements are there just for the first 3 finishes? First, second, and third. Well, 6 runners can finish first. Then 5 runners can finish second because one's already finished first. And then 4 runners are left and they can finish third. So it's really 6 times 5 times 4. You don't go all the way down to 3, 2, 1. All right, because we're just looking at the first 3 finishes. Guys, this is known as a permutation. We have kind of a fancy way of writing it here. The n is the total number of objects. All right, in our example, we had 6 runners running the race. This little number that's below the p here, the second number, is the number of objects we're arranging, or arrangement. In this case, it was first, second, and third, so it was an arrangement of 3. Sometimes we say it like this. Out of 6, how many arrangements of 3? And this is the formula. All right, n factorial over n minus r factorial. In our case, it was 6 factorial over 6 minus 3 factorial. So this bottom is 3 factorial, 3, 2, 1. And the top is 6, 5, 4, 3, 2, 1. And remember, the 3, 2, 1 can cancel out. So we end up with 120, which is what we ended up with before. I'm going to back up. All right, we ended up with 120. Again, one way to think about this is if they're saying from 6 arrange 3, just think of 6 factorial, but only take the first 3, 6, 5, 4, 6, 5, 4. We're only filling 3 slots instead of 6. That's kind of what this formula does. Here's the definition. A permutation, it's an arrangement of some or all objects of a set in a specific order. All right, the formula is there. Talk about the number of permutations, n items arranged, r items at a time. All right, this is the formula right here. An important concept to remember. In a permutation, order does matter. Order is important in a permutation. Okay? Let's look at an example. How many 3-digit numbers can we write using these 5 digits? Well, that's a permutation right here. Again, from 5, we're arranging 3. So again, that comes down to the first 3, 5, 4, 3. The first 3 numbers in the sequence of 5 factorial. And this is why it works. The answer is 60, okay? Example 2. How many different ways are there to choose a president and a vice president from a list of 8 candidates? So we're saying from 8, arrange 2. Again, here's the formula. So 8 factorials on top, and we end up with 6 factorial on the bottom, 8 minus 2. And again, that gets rid of 6, 5, 4, 3, 2 on the top and the bottom. We're ended up with just 8 times 7, all right? Because there's 2 slots to fill, president, vice president. Guys, these are a bunch of examples. I want you to look at all of them. This top example, again, from 7, pick 4. So we end up with the first 4 in the sequence, 7, 6, 5, 4. The first 4 numbers in the 7 factorial sequence, okay? Because the 3, 2, 1 cancels out. All right, I want to show you that 4P4. This is from 4, arrange 4. You see this? Guys, this is really 4 factorial. This is like the 4 books on a shelf. Arrange all of them. All right, you end up with 4 factorial. That's 24. Remember, that's how many ways 4 books on a shelf could be arranged. But the next one down here, from 4, pick 1. From 4, arrange 1. Well, guys, there's only 4 in the set. So you just pick 1 each time. You end up with 4. There's 4 ways to pick 1 from 4. Okay, or to arrange 1. There is no arrangement because you're only taking 1. All right. Last one I want you to look at, I want you to notice that 4P4, that's from 4, arrange 3, from 4, arrange 3, is 24. It's the same as from 4, arrange all 4. It's the same number of permutations, all right? Because think of it, of these 24 that are on the top here, you could just take 1 away each time. That's what they do down here, okay? And you notice that 1 factorial, it doesn't affect it at all. It's just 4, 3, 2. Just like up here was 4, 3, 2, 1. The 1 didn't matter, okay? All right, y'all, please fill out today's notes assignment. It's a little different than normal. I'm trying to make it a little more challenging. And complete the summary assessment, okay? Guys, the notes assignment today, it wants to know if you watch this. It's going to ask you like this question. What's the answer? It's going to, ask you this one here. What's the answer? All right, that's going to be the notes assignment. All right, only 2 vocabulary words today, and the vocabulary assignment's a little different today anyway. But come back into the Zoom meeting, the second Zoom meeting, and we'll do the vocabulary together. Okay, please complete the rest of the top green folder. All right, the summary and the vocabulary and the notes assignment. All right, thanks.